Hello and welcome to this build video for the Touch Me Now, which in this configuration is a touch controller with 4 pads that outputs 4 gates to have as a drum pad. Hello and welcome to this build video for the Touch Me Now, which in this configuration with the panel and the PCB, this one, is a full-fledged drum pad kind of module. You have 4 touch-sensitive pads and then 4 outputs with gates. And if you buy the whole kit, you get the panel, the PCB, and a bag of parts. And to build this, I always recommend to have the schematics at hand or the bill of material, but schematics is always good to make sure that you have that you place all the parts at the right place. So we remove some of the parts that is not needed in the beginning of the build. These are a bit special because, or this whole build is a bit special because what we do is we solder these 90-degree headers onto here, and this is so that there won't be any solder sticking up on the panel side, so the panel side is flat and nice as it's supposed to be. That one. So what do we have? We have a bunch of resistors, not LEDs, diodes, capacitors, and a whole bunch of transistors. Like so. So this is what we got. And yeah, we begin immediately. I usually like to start by adding the IC holder first. So let's try and get that in there. And now we need to start the fans, so a bit more noise. And today I have a new flat soldering tip, which should be good for soldering this kind of stuff. Because of the shape, it gets a good connection both to the pad and to the leg in a 40-degree attack angle, so to say. Hopefully. Then almost all the components on this one have the same height. But let's do it as it's supposed to in most other kits. So let's start with the resistors. And we have a bunch of 100K resistors. Let's look in the schematics where those should be. So that is R1. R2. R3, and you guessed it, R4. Then we have one more, and that is I think that is for the voltage divider. Let's make sure. Yes, R9. So the circuit is basically for comparators, and the R9 is for the voltage divider up here that goes to all the inputs of the 4 comparators, to see if we get if we're touching the pads or not. And we wait with the 10K. We then have the 1K. Those are R5. R6. R7. And R8. Then we have the 22K resistor, which is also part of the voltage divider, and that is R13. There. So that whole row in place. Let's solder them in place. And then we have some leg cutting to do. Next we have 4 diodes we can put in place, and that is down here. So that's on the outputs, making sure that we only get positive and ground out and no negative outputs. And there's a black line on each diode that corresponds to the line on each of the diodes on the silk screen, so there's an extra line on one side. That is where the black line on the part should be. So black line should point that way. Here we go. And we cut those legs off. And then I say let's take all the transistors. So there should be 8 transistors, all 2N2222, and they are set in a way to make them into 4 Darlington transistors that are really sensitive, so slightest touch on one of those pads should create a large output on at the end of each of these transistor pairs. And they can be like this. I actually suggest you put them like this so they don't take up too much space, because they're sitting like this in the middle, like that, so there's not that much space left. To make sure they stay in place when you solder, just bend 1 or 2 legs to make sure they stay. And these legs are quite close to each other, so it's important to make sure that you don't short these circuits, because then it won't work, believe it or not. And it is very tight in here, so I like to remove the legs as we go along. So at this point, this quite large tip was not that good actually. There we go. And there I got a short big time. This did take quite some time. But I believe we are done, and do an ocular inspection. Oops, sorry. Just to make sure that we don't have any shorts anywhere. And I think we're good. Clean up here a bit. And then we have the capacitors. C4 and C3 is those large electrolytic capacitors, where the long leg is the plus side and the short leg, and the white strip with a minus sign on it is the negative side. And on the silk screen you can see there is a small white line on one side of each of the two capacitors, and there's also a plus sign at the other leg. So just put the plus sign and the long leg on the same place, and the white line and the white line towards each other, and that should be correct. These pads are also very small. And it's also a place where it is possible that it becomes a short. So just make sure there is no short. And then the 100 nanofarad capacitors are the C1 and C2. We put them in there. And for the basic circuit, this is done. Now comes the tricky parts, let's say. So we can begin with the power connector. If you have a lot of room in your modular, you can put it like this if you want. But again, this will mean that the power connector will stick out outside of this. So therefore I've made it so you can place it like this. And I'm well aware that there is no white stripe or red stripe here. I will hopefully in the kit you get, I have drawn a little red line here, so you know that that is where the red line should be. And the red line also lines up with this little arrow that is shown on all of these. So basically, if you put this on, and the opening should be on the back side, and then it should be in the correct orientation with the arrow towards the bottom. And so I have those pads here, so you can actually put it on like this. That's the thing. So you place it there, and then we can solder it in place right here. And it will slid around a bit. It's always good to get one stuck first, like so. That one did get a bit placed. Don't put heat on for too long, then the plastic will melt. Gonna try to move that back. Yes, that's good enough. And of course on the top side as well, you just add solder and make sure that it gets stuck to both the pin and the pad below it. And this is of course training to these, which is the next step. This is the really tricky part and do require you to have a steady hand. So these should be assembled onto here, and then each of the legs is then supposed to be soldered onto the big pads on the PCB. like so. And to get this to work, you need to align them somewhat correct, especially the first and the last one. Those are the really important ones. So, and again, it is always good to just start with one leg. We can move all the other ones. So now that one is in place. If we now place the other one on the edge, correct. Now we can just make sure that these two are correct, so it's in the boundaries of these and they are okay to place like so. So then we just add these other two, and try to attach those as well. And once they are stuck, as they should be, you can just continue to add the legs without having the PCB connected, because it should stay in place now. There's quite a good fail-safe here. Each row, so all these 3 pins are all connected, and all these 3 pins on that side are all connected. So if you fail with 1 or even 2 connections on each of these, the circuit should still work, but it's always good to have more connections than less. I see now that mine is a bit more to that side, so it's much easier to solder on this side than on the other side. There's more of the pad showing on this side. And let's just make sure that we still can fit this on, and we can. Next step on the panel are the jacks, and the jacks are not connected to a PCB. These are free floating, so we need to connect ground to each one of them and the output. So you need a bit of cable. Hopefully you have some kind of cable lying around for this. And here's one of those times where it's kind of up to you what you want to make of this. As I've said before, this panel can be used for any touch kind of feature you'd like to do, but with this one it will just be gates, but you can make like touch. The more you touch them, the more CV they will output. There is a video on how to do that as well. But in this case, they will be gate outputs. And how hot you want the voltage output to be depends on your flavor and depends on your modular. The ones I did in my modular in a week videos, they were just directly output, so no voltage dividers on the output, so they were basically 12 or more like 11 volts just straight out, which works with almost all modules. It could be that you have a really sensitive module where that might hurt the module or destroy the module. Shouldn't. Really, all modules are safe up to 12 volts, but maybe you did a homemade DIY module that can't handle that. And for that reason, I did add, so in the previous schematics, I wrote that, it's actually in this one as well. Please be aware that all outputs are 12 volt in this configuration. If you want lower values of the output, a voltage divider is needed on all outputs. And there's an example for that. In this module, or in this PCB, I added down here, this little part down here, there is 8 diodes, and that is what those 8 resistors, there's 8 resistors down here, and that's what the 8 10K resistors are for. With using 10K resistors, you will get a voltage of around 5 or 6 volts, between 5 and 6 volts, depending on the output. So usually it's 12 volts, and then 2 10K resistors will divide that voltage by 2, so you get 6 volts out, about. There's also direct outputs here. Here you have in the middle, there are direct outputs, so these ones are not connected via the voltage dividers and can be used directly. So if you want to use this one with just 12 volt outputs on all the outputs gates, then you can use the direct outputs down here, or you can, you see R12, R15, R17 and R19 have a small white line between them. You can just use some of these legs that you used from previous, from all the components we added so far, and you can just add those like that, making a bridge over those two, over that resistor, and that will make the outputs 1 to 4 also 12 volts direct outputs. The reason I have 2 is because there are future ideas of what could be extras added to this one in the future, of course. But whichever way you choose to do this is totally fine. I'll just show you how to, I'll just add these resistors because, yeah, because we have those. But if you don't, if you just want 12 volts out, then you have 8 10K resistors you can do something fun with instead. And we just add all of them down here. Really tiny resistors, takes almost no place at all. They're shown in a standing configuration, so you need to just bend one leg like so, and then jam it in there. They are also almost so small, so they don't need to stand up, but they're made to stand up. And because they're standing up, they are a bit difficult to solder from the top, so let's just do it from the bottom. This is another one of those places where there are a lot of legs and not much room. So once we've added the outermost rows, I choose to remove those legs so we can reach the other ones. So, right, the jacks. There are 4 ground pads. If you want to, you can add each output to the to its own ground plate, or you can just connect them all together however you feel like. I choose to connect them all together now, because that is the more difficult way of doing it, and I should, because this is an instructional video, I should make it as difficult as possible, so any way you do it, it will be easier than the way I do it. There we go. And everything is so close, you really don't need very long connectors. And we just solder these together. There we have them. And as you can see, we have them here, and this one here. It's really short cables again, so we don't really need to 3-4 centimeters should be long enough. Ideally, different colors than the ground is always good, but again, just showing the most difficult way to do it, and that works as well. These jacks are normally connected over these, so it is important that you connect it in the upper lug of the connector. So you have ground down there, and this one should not be connected to anything, and this one should be connected. Otherwise you will actually remove the connector when you plug a cable in. This is interesting. Oh, come on. And remember, ground down there and the connection up there. This one does not want to be soldered in a good position. Actually, this one was better. All right. So let's put these in place here. Alright, I lost two nuts. What's happening here? Alright. There we go. And the final one. So we now have the 4 outputs here, and depending on how you did with your ground, you have 1 or 4 ground connectors. I'm going to begin to put my ground connector in place, so I won't mess that up, hopefully. And then we can connect all the others. And I want to have them all on the top side here. Let's see, number 1. This one is number 1. Add number 1, and it is from the top 1, 2, 3, 4, of course. And the next one on the same row is number 2. So take number 2 down there. Whoops. And number 3 is the bottom one. That one. And finally, number 4. We have to screw that one up a bit to make it really short. But that should work anyway. Really doesn't matter. So it should now look like this. Everything connected except the pads to the PCB. So now we move this in place, and it should be able to stand there quite well on itself. And you should make sure that the big pads line up with the pins, and that should naturally happen on both sides, of course. And again, all 3 pins are connected, so if there's a bad connection between one pin on each of these and each side, doesn't matter that much. So add loads of solder and loads of heat. we go. And the other side. And this should conclude this build of the Touch Me Now gate controller. It is always good to just make sure that there are a few places where we do not have a short. For example, between +5 volts and -12 volts, and between ground and the same pins. Ground and ground should of course be shorted. And also it is good to check so these aren't shorted. I usually check these so they're not shorted, but sometimes it might slip my mind, because it does happen that there could be a tiny bit of connection between these two, and usually it's just a small piece of solder that has gotten bridged one of the places, and then you just scrape it off with a sharp knife or something like that. Should of course add our TL074. And in the correct way, you have that indentation on the silk screen, and you should also have placed the IC circuit in that IC holder in that way, and also the IC circuit now. So the indent on the IC should point towards the panel. And there's no LEDs or something showing that it is working, so we need to go to the modular and connect it to see so the outputs are working. So I have it here now connected to my power input, and I also have the two outputs, 1 and 2, connected into a peaks module, and as you heard, it's working. As you can see, this is also a suggestion I might have, is to if you're gonna use it as a performance instrument, which I guess you are, because it is after all a performance kind of module, then install it upside down, because that way you will have the pads on the correct side and the cables will not be in the way for you, like so. So thanks for watching, thanks for building and or DIYing one of those, and hope you will have much fun playing with it. Take care, bye.